G'day, it's Clive Rocksinger here. Going from a design when you're not an electronics technician to putting lighting into something sounds like an easy task when you see them do it on TV, but I can assure you not only is it hard, but you're going to end up with this. I just did this. Look, I'll show you what I did. Right, I'm doing this design, and I was nearly in tears setting this up, so I wrote all this stuff, and I actually had a video of my own how to do this. And I remembered when I saw that picture there how to do it, so I used all this information. That was what I designed, and that's what I want to get. I want to get that lit up. I can 3D print that out, but I want, obviously it's got lights on it. So to get the LED working in a circuit, in order to set it up to design this thing, I ended up with this. And if you think you're going to do it with anything less, you are mistaken. This bullshit that they teach you with electronics, all you have to do is just a little circuit. Where's the LED? There you have it there, right? 2 volt, 1.99 milliampere, 1.993 volt. These people have benches that are nice and big and lots of room, and oh, just get the multimeter and he'll pull it out of its own little home. It's all fine and well if you got $400 million. My house cost me $130,000, I think. I own my own house, but I'm fortunate to set up. But when you buy a house, you're looking at heating and cooling. You get a small house because it's easy to look after when you're living by yourself, and so you don't have a big house because it's too expensive to heat. These people have got that much money that they can afford to have this huge bench to work on and brand new equipment, and I'll just go over and buy some new. I mean, if you can do that, what bother freaking doing electronics? Just buy a freaking yacht and, sail the Caribbean all year. I'm doing this because I'm trying to make a quid out of it. But I ended up with this. That I could arguably, I could put forward the argument that little thing there cost me $2,000. It cost me $1,300 for 3D printer, and I had to design for a year before I was capable of designing that. But you need all of this stuff. And there's no way around it, because what it comes down to is that you'll have bad leads, you'll have a bad LED. You've got to. I actually bought new. I finally got myself a mechatronic lab type setup. I've got these things here, which I bought from Spotlight. I've labelled most of them, and that's going to be a full set of resistors. But of course, when I went to get a 470 ohm resistor, I couldn't bloody well find one. And I've got my own tried and true one here, which I have. Place is a mess, of course. And this is my usual resistor. Come here. My usual resistor box. And that's the one that I've been using. And luckily I had that. And I've got your 470 ohm resistors in there, so that was partly successful. The high current tower, you've got to have your solar array, solar panel. You've also got a battery. I've got the battery up there. What do I do with the battery? I'll just what do I do with that? I've got the battery there. Also, you've got to have. Oh, come here. You've also got to have an actual manual charger, because the battery might not be charged up when you're testing the circuit out. That's the battery that I bought for it. I've got the charger there, a brand new one. So my 3D design is there, and the LED setup is here. Now I've got to do a lot of mathematics and figure out how to design a comprehensive circuit. I've got Arduino, but for the first time in my life I've gone from doing a design to getting a circuit working that's intended to be designed into the model here. And it's the first time after 42 odd years of doing this that I've done it successfully. And it was really hard. I was nearly in tears setting this up thinking, "What? This is so simple, why am I having so much trouble with it?" Because of all the things that you need to do this. And you gotta have the capacity also to know how to test leads, and you need an enormous amount of equipment. You got to make sure that you got charged up batteries all the time, and you can't even run rechargeable. You can run rechargeables in these ones, but a lot of the devices don't like the rechargeable because they don't charge up fully. So there's a bit of a downside to the rechargeable batteries. But so I'm looking good now. So I can now go do a design, and then I'll take you right through the whole process of putting lights in it, and you won't get any electronic show to show you how to do that. Oh, it's real easy. Yeah, I'll just lay it all out on the bench here. If you've got a frickin' house, it's going to be a shoebox. Trust me, unless you got, $2.5 million, hanging around. This place cost me a fortune. But yeah, I've been chasing this for years, and I'm finally there, and I'm so happy. But I was nearly in tears setting this up. Oh, go on. There you go. There she goes, she's working. 1.995 volt. You turn her off. There you go. So, very, very happy. Next stage will be to design this, to set all the wiring and stuff. And I got to tell you this, PLA doesn't like heat at all. If you leave PLA, I kept my PLA outside, and on a hot day it all warped and bent. Every model I put in there was all damaged. It can't stand heat at all. Even a hot day it'll melt and warp. So you'll eventually have to move on to stronger materials and thicker infill on that. But yeah, there's quite a bit you've got to learn about 3D printing. But anyway, Clive Rocks here, over and out.